Let's move to the question number 31. A compound microscope has an objective of focal length 2 cm and eyepiece of focal length 5 cm. An object has to be placed at the distance of 2.4 cm away from the objective for normal adjustment, the angular magnification and the length of the microscope respectively. Now dear student, the final image is at infinity for the normal adjustment. Then the magnification is V0, U0, D upon Fe and inverted, so minus. The length of the tube will be equal to VO plus Fe. Now, what is given? FO is given equal to 2 cm and Fe is given equal to 5 cm. UO is equal to 2.4 cm. 1 by V0 minus 1 by U0 is equal to 1 upon F0. Now V0 we will calculate and U0 is given minus 2.4 and F0 is given 2 cm. From here V0 comes to be 12 cm and hence the length of the tube become equal to 12 plus F is given 5, 17 cm. And to find the magnification, the M is equal to V0 and V0 has come to be 12 and U0 was equal to 2.4, D is 25 and Fe is equal to 5, and to solve it, this become equal to minus 5 into 5, this is minus 25. So your options are that magnification is minus 25 and the length of the tube is 17 cm. And look at the options. The option third is minus 25 and 17 cm. So therefore the answer to this question is option number 3. Question number 32 says, a boy can adjust the power of his eye lens between 40 diopter and 60 diopter. If his far point is at infinity, then his near point will be, these are 4 options. Now dear students, this is your eye lens. The rays are coming from infinity and the image will be formed at the retina. And this is at F. Now what is given? It has two powers, 40 diopter and 60 diopter, and when the eye is relaxed, then the focal length will be maximum and power will be minimum. Therefore, in this case, F will be equal to 1 upon 40 diopter. The F become equal to 2.5 centimeter. So exactly this distance of retina from the eye lens is 2.5 centimeter. In the second case, to find the near point, as the object is approaching closer and closer, the image will be formed at the retina. This is again at 2.5 centimeter. Now here should be the object. To view it, the image is formed at this point and this should be your near point. You have to find the near point and this lens is with maximum power and the power of the lens in this case is 60 diopter. Therefore, the focal length of this lens will be equal to 1 upon 16 diopter. So this become 100 by 60, 5 by 3, the centimeter. So to find U, so 1 by V minus 1 by U is equal to 1 by F. V is 2.5 and you have to search and what is F equal to 5 by 3. And this value gives that U is equal to minus 5 centimeter. Therefore, the near point of this eye is at 5 centimeter. And the option number 1 is 5 centimeter. If I write to answer to this question is option number 1. Let's move to the next problem. The question number 33 says an astronomical telescope has an objective of focal length. Objective has focal length of 100 centimeter and an eyepiece of focal length 2 cm. The telescope is focused to see object 20 km from the objective. The final image is formed at infinity. The angular magnification produced by the telescope. Now dear student, final image is at infinity and obviously the object is also at infinity, 20 km. Then in that case, the magnification is equal to FO divided by FE. And FO is given 100 and F is given 2. So magnification will be minus 50. And the option number 1 is minus 50. To answer would be 1. Let's go to the question number 34. A prism can produce a minimum deviation in a light beam if 5 such prisms are combined with the opposite prism angles, then the minimum deviation that can be produced in this beam is. Now dear students, there are 5 identical prisms like this, one, and the second one is reverse like this, then third, then fourth and fifth. As this ray enter into this, there is a deviation of delta, but the second lens is placed reverse with same angle of prism and material, so this will produce the deviation of minus delta. Now when the ray crosses this one, the deviation will be delta, and the next deviation will be minus delta, and the last deviation is delta. So therefore net deviation in this case is equal to delta. Your option second is delta. So answer to this question is the delta. Answer is 2. Question number 35 says, Huygens principle of secondary wavelets may be used to, first is, explain the particle behavior of the light, explain Snell's law, find position of secondary wavefront. Now dear student, the wave theory of Huygens was based on the wavefront, and we can find the position of the secondary wavefront if we know the primary by geometrical construction, and it could explain Snell's law. Whereas the particle behavior was given by Newton. So answer to this option is 2 and 3. Therefore, the answer 4 is the correct option. Both 2 and 3 are correct.